we kind of kickstarted the whole home studio revolution in India. We'd like to think we did that because we kickstarted with, the affordable audio interfaces from M Audio and MIDI keyboards. And we gave some of the first, right down, we'd like to say Oscar winners and Grammy winners, many of them in India. I don't need to name our friends. We're all friends of ours who got their very first home studio gear from Pro Musical. So we're really happy to be part of that whole movement. Today, it's going to be a very quick and a short and sweet session from somebody really special, and that's because we chanced upon a friend and associate, Xavier Metzger from Focal, who was with Focal at the time, and who is now heading the marketing at SPL, which is the company we are all here to welcome into India today. Welcome as in through Pro Musicals as their sole distributor. And that's the big news we are launching today. And that all came about through, through our association with Xavier. So we've got a big thank you to say first for Xavier for putting us on with this association.
Well, I'm just choosing the best. That's it.
Yeah, and there's lots of exciting stuff coming, so I won't get in your way. The gentleman I want to introduce you very quickly today is the founder of SPL. And SPL, as you know, is a leading manufacturer of hardware for mixing, mastering, tracking, and now as well as audiophile equipment. They've been around since 1983 and have made some of the legendary equipment that we know in the industry, such as the Vitalizer, the Transient Designer, the ubiquitous Transient Designer, which all of you know. They literally brought in a whole section of gear, the Phonitor, the headphone amplifiers, which have made themselves, a huge mark in the industry. The Ion mastering compressor, and many, many more pieces of gear. What strikes us about the company is their dedication to what they do in terms of amazingly radical technology, which you guys are all going to hear and ask. The very person who brought it all to us. I'd love to introduce Hermann Gier. How would I pronounce that?
Hermann Gier.
Hermann Gier. And Hermann is the founder of SPL. And it's a very rare occasion that many of you as engineers get an opportunity to connect with, the very gentlemen who are shaking this industry by the roots. And one such gentleman is Hermann. So without any more delay, I hand it over in the able hands of Hermann, who's going to run you through what today's subject of 120 volt technology, and he will take you through what makes SPL truly unique. Over to you, Hermann.
Thank you, Sudhin. And hello, everybody. This is a cool event. I'm looking forward to it for like a few weeks now that we're planning it. So it's going to be really special, and also for me. So right from the get-go, I was promoted as the founder. I am the co-founder. So there is Wolfgang Neumann, my good old friend and partner, and he is the true boffin. I am just the guy who is making the products, but he is the guy who is digging into the circuitries. I know my share about it, but not as good as he does. So I have to give many of the credits to him as well. Today, what we want to do is I want to share with you a little presentation, and I talk you through it on our 120 volt rail technology. Why we are doing it and what are the specialties about it. This is part of this presentation. So feel free, if you like use your chat and you come to a point where I say, hey, I don't get this, I don't understand it, hop in, write something in the chat. Sudhin and Vivian will promote this to me. I also see the chat here, but I maybe be a bit distracted. You can interrupt me anytime. That's all good. And then we talk this through. The goal of this is not presenting SPL and 120 volt and how great we are. The goal is that there is an understanding for the reasons why we do these things, why we invent these technologies, and what are the benefits for the users of that technology. Okay, so let me share the screen, and I hope that goes smoothly. So can you see this 120 volt rail screen, everybody?
Yes, it works.
Okay, so right. Then let's start here. So yeah, 120 volt rail, improving audio quality, and that's the entire goal why we designed this. Just from the get-go, a little bit of where we actually are located. You're in India, that's far down right there. This is Europe, and we're pretty much in the center of Europe, right on the borders to the Netherlands and to Belgium. So let's focus in on that area there. So you can see this little dot here. It's in that nature resort area, right to the Dutch border, which is here. This is the Belgian border. This is Belgium over here. This is Cologne, a city you might probably have heard about. And if you're into soccer or football, Mönchengladbach, that's my home team. Yeah. So our premises here, this is our building, and everything we design is being designed here in that building, and over here in that building, that's our manufacturing. So we design not only in Germany, we produce in Germany. We got people there, real people, working the products, building the products, testing them, packaging them. Okay, 120 volt rail. Let's start from the very top of the things. Now, we all know we have a wall wart and we have a plug, and there is 120 volt, 115 or 230 volt AC coming out of that wall wart. That goes into the units, right? Then you have a transformer here, and that transforms an AC voltage, a huge one, to a smaller AC voltage that goes to the rectifiers. And the rectifiers then make a DC voltage out of that. DC stands for direct current. So AC/DC, we all know that bad. So, and everybody in the industry, most of them, I mean, there are only a few exceptions, use op amps that are being run on plus and minus 15 volts. So like this. And this is like equivalent to a 30 volt DC rail. Now, everything that that performance-wise that is being done with these building blocks, with these op amps, is later on decisive for the overall audio quality of the unit. And it doesn't really matter what it does. If it's a compressor, an EQ, or whatever, everything is limited to what the capabilities of that op amp are. Now, we want to go beyond that, and let me see, and we want to increase dynamic range. We want to increase the headroom. We want to reduce risk distortion, and we want to reduce noise. And all of these things can only be improved when you work with a higher operating voltage. That's mandatory. There's no way around it. So, but if we use a higher voltage, and let's say we're going to put 60 volts into an IC, well, this IC simply, it's not as dramatic as this one, but it actually really burns. It, yes, and it's damaged. So we can't use that. And because of that, we needed to start designing our own operational amplifier. So the very core of what we do is a proprietary technology that we developed ourselves. Already started that development back in 1995. That was the time when Wolf said to me, well, if we're gonna keep using those ICs, we're in most cases not gonna be any better performing than any other company in the world. And as they most likely have cheaper facilities to manufacture, then we are going to be the one who lose that race. So if we want to be the ones to lead technologies, we need to have our fundamental core technologies built on a higher rail. I said to him, yeah, I get that. And I know that Avalon does plus and minus 30 volt. GML, George Massenburg Labs at the time, he did plus and minus 24 volt. These two companies, they designed their own op-amps, discrete op-amps to run a higher rail. And I said, so at what voltage are you aiming then? And he said to me, well, it's plus and minus 60. I said, what? Double of what Avalon is doing? 4 times of what everybody else is doing? Yeah, because it's going to be a logarithmic thing. You need an exponentially more voltage to get a certain improvement on audio, because all audio parameters are mostly logarithmic. And the voltage increase is linear. So to achieve something in that direction, you need to ramp up the voltage a lot to get a little add on the performance side of the audio. So yeah, we had that, the 4 times voltage for the. Now let's talk about what improvements that actually delivers if you use such an supra op amp. And the first thing is obviously dynamic range. Now we're comparing here the standard 30 volt rail with the 120 volt rail that we use. And you have like 124 that you can get out of an IC with that kind of rail, and 1.4 you get that out of a 120 volt rail device. Op amp, not device. So the next thing we want to look at is total harmonic distortion and noise. That's minus 106 to minus 114.2. Now, why is that important? And we're going to take a look at when we're using a DAC chip in our designs, and we're going to opt for a 4490, which is a premium DAC, really nice sounding. Then the specs out of the output of that DAC is a THD and noise of minus 112. So that's the line, the red line you see here. And that means that if you use standard technology, you cannot keep up with the performance, and you lose like 60 dB of performance at that point. Whereas with our technology, you don't lose any performance. There is still we still have a better THD than this kind of chip does. So the IC cannot keep up with the DAC, and we perform better than this kind of DAC. There are better DACs available as well. They are esoterically expensive, and this figure might be going down, but that only means that the distance between the standard rail IC and the high-end converter becomes even bigger. Now, let's take a look at the third thing, that's headroom. And headroom means how much level you can put into a device before it distorts. And it's between 21.5 for an IC and 33.2 for a 120 volt rail supra op amp. Okay, let's take a look why this is important. Now, if you use a converter, you can set the DA converter to put out a certain level, a dBu level that is equivalent to a full-scale digital signal. So 0 dB FS stands for full scale, obviously, equals plus 18. If you select that on your converter as your reference, then what you see is that with an IC device, you only have 3.5 dB of headroom remaining. Whereas with, okay, that means that if you're already operating at the edge of the operational voltage that the IC can cope with, that IC is getting into stress, and this kind of stress creates the coloration. Now, in many cases, when people talk about Oh, this product sounds like more mid-rangey and a bit edgy on the top end, or a bit smeary on the base end, or they have certain attributes that they talk about with gear. Most of that actually is derived from the fact, how does the op amps behave when they are at the edge of their performance? And because of that, the products have a certain sound, and how you deal with that sound is giving that the criteria of why people like it or dislike it. But we said, hey, we use these products in mastering mostly, and in professional fidelity, our hi-fi line. And the least thing we want is unwanted coloration. What we want is reproduce what I'm working on, reproduce my work, and not put any color on it. If I want so, I take a device that does that, but that should be the choice of the engineer, not the choice of the general equipment you're using. So that was the intention. It was actually brought to us by the mastering engineers at the time in the late 90s then, who coped with increasing levels and performances on the DA converter side. So at the time we went from 8 to 12 to 16 to 20 bit, and we got single sample rates, but then the double sample rates came in the mid 90s, and in the late 90s we looking at quadruple sample rates, and they were actually really fed up with that, because in mastering they were like constantly listening to new equipment that was coping with the advancement of digital technology and the products that go along with that. And as they wanted to keep themselves ahead of the curve, they had to literally learn about products and how they sound every other month. And they said, we can't work like that. So build us a console that is analog, that stays analog, where we can monitor everything with, and that has no effect on the sound, that performs better than any of the digital. So that was actually the time when we started to build the first mastering console, and I come to that later. So with our 120 volt rail, you still have like 15.2 dBs of headroom if you run your converter on plus 18. So there is no stress, and that means there is no coloration, and you have a giant processing headroom. Imagine with the 3.5 dB over here. Well, yeah, you just have to use an equalizer and do a bit of stuff on the bass end, or wherever you want to increase frequencies. You drive this little baby nuts over down here, and it creates distortion and coloration, something that you don't want. So now there are converters out there that even go up to plus 24 dB. So that's another 6 dB higher. And if you then use your standard rail technology and your units with that, well, you plain simply run into distortion. And no wonder why you think, hey, this mix doesn't sound right. It's not that the mix doesn't sound right, the reproduction chain doesn't. With our technology, there is still an amazing headroom of like 9.2 dB on top of that. So here, well, that's a no-go, but with that technology, you can do 24 dB and you still have everything you want. So that already gets us to that part, to that end, and we can run through questions if you like. We truly believe it's the world best audio path. Yeah, we do. Yes, we have the highest headroom. That's a given. The biggest dynamic range, that's a given too. And the lowest THD noise as well. Anybody with a question with that, or I was just hearing somebody talk? All right, no way. Yeah, reduced ear fatigue. That's also down to the reduced distortion. The THD is always what drives your hearing into like fatigue, and you cannot listen for long, especially when you use headphones. That becomes apparent. And our headphone amplifiers, the Phonitor series, they run on 120 volt rail. The Phonitor 2, especially on the production side, on the studio series. So that also gives you hours to work with headphones without getting fatigued. Now, people always ask us, how would you describe that sound? Well, one thing definitely, it is effortless. It does the job and you don't notice it. You don't hear electronics. And that was our goal. Don't make electronics audible. They should just not be there when you listen to them. precise, but not edgy. That's important. Sometimes precision goes along with edginess and harshness, and you have to make a trade-off between that. I always find this a pity, because if a lack of precision is down to, yeah, I needed to get the harshness down, that's sad. A huge sense of spatiality. Yes, that means that when you listen to this, you can literally listen deep into it. You hear the faintest little noises and parts of the music in the distance, reverb flags, delay tails, what all these things, they stay maintained for a very long period, and you can hear them even if they're really, really small. So the masking effects are being reduced. And it brings microdynamics to full life. And that's exactly that's very important, because we all strive in mixing to get microdynamics alive, and that is what makes music exciting. So but when you don't hear it in your monitoring system, how can you possibly work on it? And in most cases you overdo it, because your monitoring channel is eating it away. It doesn't get to your ears. So you work on your part, you change parameters, but you don't get it for good. That's not because what you do is not right. It's because what you're listening to and that flow cannot cope with that. And the most realistic sound reproduction. Yes, we believe that. Again, because you don't hear the electronics, you just hear pure music as it is, the best way possible. There may be better, superior technology come along one day, and we hopefully develop that then. But for now, I can only say that the 120 volt rail is giving you this. Okay, that's actually it. And I guess I have, let's see. Oh, yeah, this is a little video that you probably have seen it on our website, but I wanted to share it with you because it's kind of nice. So what we do here is we just to give you an idea how well this technology actually is. So we use a Voltair XE and headphone amplifier, and we use the Audio Precision Cascade 2. So here, Wolf is now interconnecting both in and outputs. So you can see here, the red and the yellow are the outputs of the Audio Precision. They are lying here, and the blue and green are the inputs for the Audio Precision. He effectively loops them together, and we're measuring THD and noise. So we're at minus 113.5. That is what the Audio Precision is capable of. Okay, and now what we then do, we're going to break this open, and we put the Voltair XE in between. So Wolf is putting the inputs into the unit here on the back side. And on the front side, he's connecting the headphone output. And we're not talking line, we're talking full throttle headphone output. So we're ramping this baby up to the max. You cannot listen to this and just would blow your ears and your mind. But the thing is that if you, this is the output. Now this goes back to the Audio Precision, and the measurement, oh shit, I fucked it up. I'm sorry. The measurement stays exactly the same. Yeah, that was unfortunate. Come on. So where were we? I was just hitting the wrong button here. Yeah, we have that already. So let's jump forward. And you see it now we're connecting it from here to there, full throttle, front output. We're going back to the Audio Precision, and it's the same. So that means that what we're actually we don't know from this kind of measurement how good our technology really is, because we measure on the measuring system. Well, in fact, what we did, we are boosting then the output with 120 volt rail of the audio position to drive our system into saturation and then to measure that point. That's what we need to do. Meanwhile, we're having another and a follow-up unit on the audio position, so we can dig a bit deeper on that. But on that video, you can see we're as good as the Cascade 2 and even better.
Herman?
Right. Yes.
I think we do have a question from Sartak.
Right.
Sorry, it's not a question.
Oh.
I have a class to attend from my college actually right now. So is it fine if I leave?
Say it again, because we didn't catch that. Please.
I have a class to attend, like from college. So I mean, I have to leave.
Oh no, yeah, no
Also.
problem. Sure.
Yeah.
No, thanks for attending anyway.
Thank you. I'll join the next one.
No problem. Thanks a lot.
Thank you.
Yeah, he just had to leave, and he was sorry, so he just had to leave.
Okay, fine. Yeah, here this is yeah, Bob Ludwig. You probably all know him. He's really as funny as he looks up here, and he's probably the most awarded mastering engineer on the planet, and he has one of our big MMC1 consoles that we installed in 2002 in his place, and he's doing all of his mastering since then. So for the last 18 years, he's using that, and he, every time we speak, he's just saying, well, nothing has surpassed what you did there over the last 18 years, and I'm so pleased to work with that. I can always go back to, this is my reference point, and I can work on with a very stable base fundament, wherever I can rely on what I hear. So he's always really yeah, thankful for that. Yeah, and we're too, because he really digs it and he loves it. And here are just a few more pictures of people using it. I couldn't put all of them on there. It's just like, yeah, I don't know. I'm not fishing for compliments here. I'm just letting that run through. So yeah, but that's actually my little take on the 120 volt rail. And if you, yeah, come on, if you have anything to ask, this is the time.
Was pretty clear, apparently. I do have a question that does not rely on the Voltair. I have a question. You're gonna love it. Are you planning to expand your monitor controller range to accommodate Atmos for OTT workflow, something on the lines of, say, GBL Intonato? Knowing that we have a session about the monitor controllers, and it's going to be next Tuesday. That was just for the advertising.
Well, we have a monitor controller that is a 16-channel monitor controller in 120 volt rail. That's the MC16. So that's an all analog 120 volt rail device. It can, you can make presets for any kind of listening, not just Dolby Atmos. You can configure it for Aura 3D or for Sony 360. Yeah, there is. We're thinking about that, but the Atmos environment, there are many takes on it. Not just the multi-channel, but also the stereo headphone playback with Atmos. So there are many things to think about, and we're actually right now looking into this technology and how people are using it. Obviously, we've been a company that has been involved in surround for a long time, and in 1998, we came up with the first main microphone array to record 5.1 surround, and that was called Atmos. And I trademarked it. It was my name. And I left the trademark in 2012, I guess, 2013. And a year later, Dolby took it on. Damn it. But the thing is, I mean, surround was also always our thing. We did almost sort of monitor controller. We even did a product for Sennheiser called the Asphyra that was used on the football championship in Brazil in 2014. So that was a device that could take stereo recordings and made 5.1 out of it with an algorithm that was designed by the Swiss company Illusonic. You can hear the way I talk about it. My disappointment is with surround audio production, I have to say. I've seen 5.1 come and go. I've seen 7.1 come and go. I've seen Dolby, DTS, the ProLogic things went away. There were so many formats that tried to make their way into music, and all of them, literally all of them, came from cinema. And we tried to find content to fit those channels that were used by cinematic playback channels. And I remember the time when everybody was like juggling around with joysticks on the console to play some mono or stereo that they had on multi-track to position it somewhere. And like the worst example, a hi-hat from the rear or something like that. I have my true doubts over all these years that the music production in full stack surround in 7.1.6 or whatever it is, or 9.1.6, that we will see real music production working for that. And the more I talk to engineers about that, there is a certain amount, and please, this is only my opinion. No, don't take this. Everybody can have his own opinion, but it's just my take on it.
Oh, hey, hi.
They actually said that the record companies are asking them to make the music reveal Atmos content, meaning they were literally one friend of mine, he has a huge mastering place in Berlin, and he and the record company said, yeah, well, we like your Atmos mix, but it's not really, I mean, it doesn't show off Atmos, what it's really capable of. And he really like, yeah, it's music. I mean, their band is playing there, and what, okay. And then he sent them an audio or a mix where he took the snare and let the snare rotate above your head. And it was a joke. And he sent it to the record company, and the A&R guy said, wow, we never heard anything like that. Now that's really promoting the Atmos format. And he went like, holy. See, this is where I'm afraid of a bit, that we're losing the music content that A&R managers decide upon to feature a format, and that makes our music composition or influences that. That's the wrong way, isn't it? Yeah, so right now Dolby Atmos is the big thing, but I'm not sure whether it's just a big thing because Dolby is paying all the studios to ramp up for it, and to even promise to pay for the back catalog remastering in Dolby Atmos. I'm not sure. All I know that if you're not promoted by Dolby, the record companies don't give you any additional money to do Atmos. So you do stereo, and then the rest is your job. That's also not healthy, because the studios go for an investment, but then they go for an investment. Let's say they're going to put like 16 speakers in their studio, and people are listening on standard headphones. I mean, that doesn't compute to me either. So, okay, I'm done with that. It's probably a bit biased. You can feel that I'm not a big fan, although I am a surround fan, and I did it all my life. I even did Formula One races in 5.1. I was the only one doing it for like 2 or 3 races broadcasted. Never happened again because the effort is just extreme, but we did that because we could. I love it, but it needs to be done right and for the right reasons. So that's my point on it. Done.
Okay, is there any other questions related to Voltaire or not?
Not right now.
All right.
Ritesh, you had something to say.
Hi, Hermann. It's Ritesh and Ranga from Chennai. So I had a question regarding the PhD, the lower PhD and noise. So is it mainly because we are in higher operating range, so it doesn't have to drive the op amp? Is that really the reason?
Yes, that is exactly true. We're staying at the audio levels that are actually coming in at the input, but literally our op amps are not really affected by that. They're almost like running in idle mode, if you so will. So they just, for them it's not a big thing even to cope with high levels, and that keeps them relaxed and unstressed. It's actually, I mean, it sounds so human in a way that you're gonna get stressed when you're pumped to the edge, but that's the same with pretty much everything. Think of water you press through a pipe. If it's the smaller the pipe, the more turbulence. And that's pretty much the same for electrons, for everything. If there is too much at one end, you're gonna get turbulences, and that's gonna somehow affect the performance. That's a universal thing, obviously, at some point. So to just try, okay, get that bottleneck out of the way. That was it's not rocket science, it's just doing it. And I know that many companies are literally afraid of stepping into designing their own core technologies, like an operational amplifier for audio. And that's, I need to give you this little story because that's really funny. That was an AES event where Wolf, my partner and friend Wolf, he was invited as one of the speakers there, and George Massenburg was there, and Daniel Weiss from Weiss Engineering in Switzerland was there, and Hutch Hutchinson from Menley at the time. So they invited the top 5 guys to build equalizers. Oh, and John LeGroux from Millennia Media. So these were the 5 people invited on that session. And Wolf and John are very good friends. So they are like chatting along. They get along really nicely. So that event went like all of the other events, all nice. We all love it. And I know that Wolf is a true fan of George Massenburg's. He really admires him. So and he has huge respect for his work as a producer and engineer. And I remember he was walking off stage, and George Massenburg came behind him and tipped him on the back and said, "Mr. Neumann, may I have a word with you?" And he turned around like, oh, yes, sure. And he said, "This 120 volt rail thing of yours, how does it actually work? How do you get it to work?" And John LeGroux was coming up to them. "Yeah, Wolf, how did you do that? I mean, I keep trying it and it keeps burning on me all the time. How did you do it?" And Wolf said, like, "I don't know. It just worked." And it was so funny. So, but at the time when we started looking at it back in the 90s, and Wolf was designing it. I mean, that's another story on its own. So we were looking at operational amplifiers that were actually running on 60 volt, plus or minus 60 volt. You can find them. They are not rare, and they are mostly used in satellite communication. Because that's pretty much the rail that you get out of the solar panels in space. So that's the very close voltage there. But they are not designed to do audio. They're mostly designed for HF communication in megaband and even higher. But a few of them actually had a frequency transmission that goes down to almost DC. So it covers the entire audio range. So Wolf looked for those op amps, and he bought in, well, dozens of different pairs, and started to had a blackboard with all the things on, and he just did that, and then we sat down and made listening tests. The most of them were just awful. They just didn't sound anything like you would expect an op amp to sound like. It was just not designed for it, so forget it. And at the end, we only had two out of all of them that really performed better than, and all really not just from the specs, but also you can listen to it and you just felt it. That's nice. It's really cool. So we ordered those. No, we tried to order those. Turns out these op amps were only manufactured 5 days in a year in only, and there were only 5 customers per company. Funny enough, it was identical. I don't know why that was, but they only had 5 customers, and that's it. And they wouldn't accept a 6th customer. And we're like, that can't be right. And we were like 3 years in the development, and we had it, and we wanted to buy it, and we couldn't. So, and we're like, no. All right. So, and then at that point, okay, I said to them, okay, guys, we get it. Put us on a waiting list and just call us up when somebody jumps off. That was the only way we 2 years later, we almost forgot about 120 volt Ray. We were frustrated about the whole thing. We couldn't find any other op amp that was really like cool. One of the companies actually was Fairchild, producing such a thing that you probably know as a company, as an IC company. They have the same name as a very famous compressor company in the past, but they're also producing IC. So anyway, and we got on that. They called us up. Hey guys, we have one company left, so you can jump in. You need to buy 300,000 transistors to start with. Okay, so we did that, and started to build the first op amps, and the PQ. You probably know that we made a mastering equalizer that has like fully parametric, 2 times 5 bands, and it was recallable. I mean, resettable. It had motors built in, and a computer, and you got 800 storage places, and you can dial in what you want, and then you go store, and all not. Super cool. So that was the first product we made with that. Later on, turns out we're not making it anymore because it was sort of a nightmare in terms of tolerance that the motors, the servos, and the gearbox on the motors have, and then the engine stops at a certain point, but due to the hysteresis of the gearbox, it stops there or there visually, depending whether you come from here or you come from there. Technically, it was just the same, and you couldn't tell, but visually, it was just slightly offset. And the mastering engineers, rather than listening to it, they just said, "That's wrong. It doesn't make." Said, "Yeah, it does. It doesn't look like it, but it sounds like it. Yeah, but it doesn't look like it." So in the end, it was also the temperature and everything else turned that the products were getting more and more drifts, needed recalibration. It was getting nasty at one point, so we stopped that product. And the second thing we did was the mastering consoles that we made, and one of them was for Bob. The first one was for Galaxy Studios in Belgium, and Ronald Prent, he was actually the guy who was co-designing the MMC1 with me at the time, and it was his ideas on how to. It was an 8-channel console. It was a surround mastering console. That was the design. Already a surround mastering console in 8 channels. Yeah.
Hermann, I do have a. It's not a question; it's a comment. That is quite a question. That says now every SPL product feature the 120 volt rail. Then.
Nope. Not all of them do, obviously. It is still costly, and it's still space consuming. The device is bigger than IC, and and it consumes a lot more current and voltage. So the power supplies are bigger as well, or that all drive the cost. So, but all mastering products in our mastering category are 120 volt rail. All professional fidelity products for the hi-fi side are all 120 volt rail. In the studio side, we have the Crescendo 8-channel and dual channel. Those are the microphone preamplifiers, and these are the first ones that actually use 120 volt rail. And they are literally, you cannot really distort them. Even if you do like mic drops, they would take it and they wouldn't distort. So and the Phonitor. The Phonitor 2 is also in 120 volt rail. There's going to be a process that we will do more and more products in the studio era that are running on 120 volt rail. But complex applications, for example, like monitor controlling, where you have to get a lot of inputs and outputs, and you all have to drive them active, that consumes a lot of op amps. And then the space is just not there for a little desktop device to put all of these op amps in there. So there are just physical restrictions to what you can do, other than the price point. But if you have like a form factor that you want to keep, you need to make a decision on the technology you use. And if it's going to be a small device, you cannot put huge components in there. It's a simple thing.
All right. I do not have any other questions by chat. If anyone wants to ask question, feel free before we close this first session.
Yeah, I'm just seeing here that somebody's asking on the 500 series modules incorporate 60 volt power rails. No, you need to understand that we don't supply the rail on the 500 series. The rail is supplied by the API box or by the radio box or whatever box you're using where you put your slots in. And actually the API is only doing plus or minus 16 volt. And that's what they supply as a standard. And there are other companies that use plus and minus 18 volt, which is a bit better. And that's so none of the 500 modules actually has an internal power supply. Some companies do that to drive other powers internally, and then they need an additional input to get some juice from the outside to drive their system. They have their ways to do that, but where we just use the standard rail that is supplied by the box or the device where you put the rail, the cards in. Yeah. Okay.
All right.
Yep, that's it.
Yep.
Herman, I just had a follow-up to the same PhD question. I guess my volume is a little bit low, so I'll speak a bit louder. So with the THD and noise, right, it's not always about operating it in the right range. There's also system noise, just the circuitry noise from the circuitry that can affect it. Is there anything that you do unique to counter the other sources of noise too in the system?
Oh, do you mean like some kind of noise cancellation for, or I'm not sure whether I understand your question really. Sorry.
Electric noise.
That is induced by other devices. It's not much you can do about that. No, we don't. I wouldn't know how to actually filter these artifacts if they actually come in. That's the downside to if you have it in the system.
No, I mean, but from within the circuitry too, within the device itself.
You mean like decoupling from DC and all of these things? Yeah, obviously that's a given. You need to do that to a certain. Well, DC decoupled is everything. Buffer is everything. There, we are fans of circuit protection all the way through. So that's a given. But in terms of external DC, or sometimes, let's say a product from us fails and an op amp or something goes wrong. I mean, it happens. Then and you get a DC and you get plops when you switch, especially when you use relays as switches. Every time a relay opens and shuts again, you hear like a dock, dock, or clock, 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 all these DC noises. But most of the cases they're induced from the offset that is being created between the negative and the positive path of the balanced audio connection to a following device or a previous device. DC, it doesn't matter. There's no direction. It comes from the inputs or from the outputs into the box. It goes both ways. So when the caps actually run full, they take the plops for a certain amount of time. But at one point, they're just saturated. And then it breaks through and you get like some noises like this that are very faint, but you know that now it's trying, the DC breaks through, and every time you hit a button that causes a relay to switch in the audio path, you hear that as, because there is a little spark in the relay, and that's what you hear as a plop. So then you need to just, usually what I do when I encounter something like that, that can be that an input stage or an output stage of one of the connected units has an offset between in the balancing stage between the positive and the negative audio path, and you take them off one by one and connect them. But first of all, you shut your system down and just wait for a while so that the caps can uncharge until they are flat again, and then you try to put them on, wait for some time until that, if it comes back on. The downside is that this is a process, and you need to take the time for that. So that's really, finding it is not, it's not really simple, and it takes patience to figure it out. Yeah, does that sort of answer your question? Or
It did.
Okay. Okay.
I was just going for if there's anything different. These are all standard.
Yeah.
Devices. But I was just more interested in, is there anything different that SPL does to counter these?
No. The reason is you may do more, but the more electronics you put into the signal path, at one point you really hear it, and it's a trade-off of a smeared image, sonic image, versus a clear image that is not protected over everything. So that's there is only one company I really admire for how they do it, because they achieve like their sound with that, and that's Neve. So what old Mr. Rupert did in his designs was really cool. He plastered the whole box with capacitors like mad. I mean, it's just like a fest of decouplings and everything. But he actually really knew how to do that, and he created his Neve sound by doing so. But it's the only company that I recall where I really admire this overprotectionism. But I think he didn't do that on purpose. You must think back, like in the 70s, when you start to build active consoles for the first time with active panorama and active faders that could boost signals, and filters that could actually boost, not just cut like the passive times before, that you were like confronted with a lot of issues from external equipment. Some of the equipment was so old that they don't have any protections at all, and they put their DC out to your mixing console, and everything was connected to your mixing console. So you needed to take care of all of the issues in the DC that comes in from external equipment, and I think that drove him to the point where he went to that protectionism, which from today's standpoint is a bit over the top. But it is a sound, and that's cool.
All right. We don't have any other questions, I guess. And maybe it's time to close the session, maybe. Sudin, what do you think about it?
Yes, yes, we can. If you can remind about our next session,
Yes.
Xavier.
Yes.
Yeah.
So that was the first session on 8 different sessions. The first one will be on this Friday, next Friday at the same time. Vivian and Sudin will confirm that to you, but obviously it's going to be the same time. And it's going to be about the other technologies that we developed and that we're using besides the 120 volt rail, Voltair. And then next week, we're going to have at the same time on Wednesday, on Tuesday, for example, Wednesday, sorry about that. It's going to be about Series 1 and the monitor controllers. And let me check on the Friday next week. Same time, it's going to be about headphones and amps, headphone amps and the matrix. So the next one will be next Friday, same time, same place, obviously, about the other technologies that we were using and developed. And we wanted to thank you for being so numerous and for your time.
Oh, yeah. Thanks a lot, guys. Thanks.
Absolutely.
Thank you.
Just a small reminder, if anyone wants any more clarifications or details, Vivian and myself are always available. Our emails are accessible on our website as well, and our phone numbers are there as well. The gear that we are talking about will all be coming in very, very soon. It's almost on its way. So we have a few orders on hand as well, which we're excited to share with you. So any of you looking to plan your upcoming gear requirements, please get in touch with us. Also follow us on Instagram and Facebook, because any updates or changes will be notified on our story page as well. Thank you, Herman. Thank you, Xavier.
If I may add something,
Yeah, please.
Yes, sorry to interrupt. I recorded this session as well as I will record all the other sessions. So if you want to have a refresher, or if you want to tell about this session to someone else, I will send the video to Vivian and Sudin, and then they will be able to also give you the link to this video of the session.
Absolutely, and please share this with your friends and engineers. Many of them who couldn't make it today. I know it's a working day and working hours, so really appreciate that you made it. But please do share with your friends as well on your Instagram pages. Okay, great, Herman. That was amazing, wonderful hearing about everything you had to say and all the little incidents. Fascinating, right? So over to you, Xavier. Would you like to close the and
see you on Friday?
Yeah,
that's what I have to say. See you on Friday for more
Absolutely.
stories and good stuff.
Super.
Okay, thanks a lot, and bye bye to everybody. Thanks a lot.
Thanks for your time. Have a good day.